Encoding lexicalized tree adjoining grammars with a non-monotonic inheritance hierarchy. Roger Evans, Gerald Gazdar, David Weir. Abstract. This paper shows how DATR, a widely used formal language for lexical knowledge representation, can be used to define an I_tag lexicon as an inheritance hierarchy with internal lexical rules. A bottom-up feet-oral encoding is used for LTAG trees, and this allows lexical rules to be implemented as covariation constraints within feature structures. Such an approach eliminates the considerable redundancy otherwise associated with an LTAG lexicon. Gerald Gazdar is a British linguist and computer scientist primarily known for his work in theoretical and computational linguistics. He is a key figure in the development of generalized phrase structure grammar (GPSG), a theory of syntax that aimed to provide a formal, declarative, and computationally tractable alternative to transformational grammar. Along with colleagues like Geoffrey Pullum, Yvonne Sag, and Ewan Klein, Gazdar argued that many aspects of natural language syntax could be described using a context-free phrase structure grammar, supplemented with powerful metarules and feature systems. His work has also contributed significantly to the fields of pragmatics and the formalization of conversational implicatures and presuppositions, as well as to the design of computational tools for lexical knowledge representation. Gerald Gazdar was born Gerald James Michael Gazdar on February 24, 1950. He received his education at Heathmount School and Bradfield College. He then went on to higher education, earning a BA from the University of East Anglia in 1970 and both an MA and a PhD from the University of Reading. His doctoral thesis, completed in 1976, was titled Formal Pragmatics for Natural Language Implicature, Presupposition and Logical Form. Following his studies, Gazdar began his academic career as a lecturer at the University of Sussex in 1975, where he would later become a professor of computational linguistics in 1985. Gerald Gazdar's early work can be divided into two key areas: his contributions to formal pragmatics and his foundational role in the development of generalized phrase structure grammar (GPSG). His 1976 PhD thesis, Formal Pragmatics for Natural Language Implicature, Presupposition and Logical Form, laid the groundwork for a formal approach to pragmatics, which is the study of how context influences meaning. In this work, Gazdar provided a system for generating and cancelling conversational implicatures and presuppositions, which are the implied or assumed meanings in an utterance. This research was a crucial step in formalizing the theories of philosopher Paul Grice and integrating pragmatic phenomena into a more rigorous linguistic framework. Gazdar's other major early contribution was the co-founding of generalized phrase structure grammar (GPSG). 1979 book Pragmatics, Implicature, Presupposition, and Logical Form. This book was a landmark in the field, providing a rigorous, rule-based system for analyzing and predicting implied meanings in language, thereby formalizing the theories of Paul Grice. It showed how contextual information could be systematically integrated into linguistic theory, moving pragmatics beyond a purely philosophical domain. Natural Languages and Context-Free Languages 1980. In their 1980 paper Natural Languages and Context-Free Languages, Geoffrey Pullum and Gerald Gazdar argued that natural languages can be accurately and powerfully modeled as context-free languages. This paper was a direct challenge to the long-held belief that the complexity of natural language required a more powerful, non-context-free grammar formalism. The equation natural language equals context-free grammar CFG encapsulates their core argument, which laid the theoretical groundwork for the development of GPSG and other context-free based frameworks in computational linguistics. Beginning in the late 1970s and culminating in the 1985 book Generalized Phrase Structure Grammar with his colleagues Ewan Klein, Geoffrey Pullum, and Yvonne Sag, Gazdar developed a theory that challenged the dominance of transformational grammar. The central idea of GPSG was to show that a powerful and restrictive theory of syntax could be built using only context-free phrase structure rules, along with additional formal mechanisms like meta-rules and a sophisticated feature system. This work demonstrated that complex syntactic phenomena, such as unbounded dependencies and coordination, could be handled without resorting to the abstract transformations and underlying structures of Chomskyan linguistics, making it a highly influential and computationally tractable alternative. Generalized Phrase Structure Grammar (GPSG). With his colleagues, he co-authored the seminal 1985 book, also titled Generalized Phrase Structure Grammar, which proposed a powerful alternative to the then dominant transformational grammar. The central claim was that a highly constrained, non-transformational, and computationally tractable theory of syntax could be built using only context-free phrase structure rules, enhanced with formal devices like meta-rules and a rich feature system. This work was a watershed moment, demonstrating that a declarative approach to syntax could successfully account for complex linguistic phenomena, such as unbounded dependencies and coordination. Gazdar and his co-authors also wrote several key papers in this period, including Unbounded Dependencies and Coordinate Structure 1981, which further solidified the empirical power of the GPSG framework. Gazdar continued his work in computational and theoretical linguistics, particularly focusing on the formal representation of language. A significant paper from this period, co-authored with Ewan Klein and Jeffrey Pullum, was a note on subcategorization, constituent order, and the notion head 1985. This work delved into the detailed workings of syntax, showing how the GPSG framework could handle complex relationships between words and phrases without relying on transformational rules. Generalized Phrase Structure Grammar 1985. In their 1985 book, Generalized Phrase Structure Grammar, Gerald Gazdar, Ewan Klein, Jeffrey Pullum, and Ivan Sag introduced a groundbreaking framework for generative grammar. They proposed that a single, enriched phrase structure could encode both syntactic and semantic information, thereby avoiding the need for multiple structures or the complex transformations required by other theories. This approach, summarized by the equation syntax plus semantics equals single phrase structure GPSG, challenged the dominant transformational grammar of the time by demonstrating that complex linguistic phenomena could be explained with a simpler, more computationally tractable model. Gazdar also played a role in the evolution of grammar theories, and his earlier work had a direct impact on the development of head-driven phrase structure grammar HPSG. HPSG, which was co-developed by his colleague Ivan Sag, took many of the key ideas from GPSG such as the use of a rich feature system and a lexicalist approach and developed them further into a new framework. Category Structures 1988. The 1988 paper Category Structures, co-authored by Gazdar and his colleagues, proposed a feature-based approach to grammatical categories. Instead of treating categories as indivisible units, they argued that they could be defined as bundles of features. This method, represented by the equation grammar equals feature bundles plus category relations, enhanced the descriptive power of GPSG. By using feature sets, the framework could capture subtle grammatical distinctions and relationships more effectively, providing a more flexible and robust way to formalize syntactic structure. Encoding lexicalized tree-adjoining grammars with a non-monotonic inheritance hierarchy 1995. In their 1995 paper, Gazdar, Evans, and David Weir extended the capabilities of DATR to a new domain by showing how it could be used to encode lexicalized tree-adjoining grammars tags. The equation tag plus DATR equals lexicalized grammar encoding summarizes this contribution. By integrating the formalisms of tags with the non-monotonic inheritance system of DATR, they demonstrated a powerful method for structuring and representing a grammar's lexical components, thereby improving the computational models used for natural language processing and parsing. He was a key figure in the creation of DATR, a declarative language for representing lexical knowledge. Papers like DATR, a language for lexical knowledge representation 1996 detailed the system, which was designed to model the complex inheritance networks and regularities found in a language's lexicon. This research provided computational linguists with a powerful tool for building and managing lexical resources efficiently. Gazdar also contributed to a series of educational books, such as Natural Language Processing in Lisp and Natural Language Processing in Prolog, both 1989, which were instrumental in training a new generation of researchers in the practical implementation of natural language processing systems based on the principles of unification-based grammars that his earlier work had helped to popularize. DATR, a language for lexical knowledge representation 1996. Gazdar's work with Roger Evans in the 1996 paper DATR, a language for lexical knowledge representation introduced DATR, a specialized language for encoding lexical information in natural language processing. This language uses a powerful non-monotonic inheritance system, which allows for the efficient and structured representation of lexical knowledge. The core idea, captured by the equation lexicon plus inheritance equals DATR representation, is that a language's vocabulary can be organized in a hierarchical network where general properties are inherited and specific exceptions are handled with precision. In his later career, Gazdar's influence extended to areas such as unification-based grammar frameworks and the formal properties of language. Although he was not a primary author of head-driven phrase structure grammar HPSG, the framework was heavily inspired by the ideas he and his colleagues developed in GPSG. HPSG adopted and expanded upon many of the core principles of GPSG, such as the use of rich feature structures and a non-transformational, declarative approach to syntax. Gazdar's work provided the intellectual foundation for this and other subsequent theories, solidifying his legacy as a key figure in the shift towards computationally oriented, non-transformational models of grammar. His research demonstrated the value of creating linguistic theories that are both formally elegant and practical for real-world computational applications. In 2002, Gerald Gazdar revisited his foundational theory of generalized phrase structure grammar GPSG with the paper, A Simple Reconstruction of GPSG. Published well after his initial groundbreaking work in the 1980s, this paper provided an updated and simplified view of the framework. Gazdar's reconstruction aimed to demonstrate how the core principles of GPSG, such as the use of a context-free grammar with powerful feature systems, could be presented in a more streamlined and elegant manner. This work served as a testament to the enduring relevance of his ideas, showing how the non-transformational, declarative approach to syntax he championed continued to be a viable and powerful alternative to other linguistic theories even 2 decades after its initial formulation. As there is no public record of Gerald Gazdar's death, it is presumed he is still alive. He was born in 1950, which would make him 75 years old as of 2025. He retired from his position as Professor of Computational Linguistics at the University of Sussex in 2002. The specific reasons for his retirement are not publicly documented, but it is common for academics to retire after a long and distinguished career. Phrase structure grammars and natural languages. Gerald Gazdar. Abstract. During most of the last 2 decades, computational linguists and AI researchers working on natural language assumed that phrase structure grammars (PSGs), despite their computational tractability, were unsatisfactory for expressing the syntax of natural languages. At the same time, they realized that transformational grammars, whatever their linguistic merits, are computationally intractable as they stand. The assumption, unchallenged for many years, that PSGs were inadequate for natural languages is based on arguments originally advanced by transformational linguists in the late 1950s and early 1960s. However, recent work has shown that none of those arguments were valid. The present paper draws on that work to argue that, I. There is no reason at the present time to think that natural languages are not context-free languages. 2. There are good reasons to think that the notations needed to capture significant syntactic generalizations will characterize phrase structure grammars or some minor generalization of them, and 3. There are good reasons for believing that such grammars, and the MO2 nostatal representations they induce, provide the necessary basis for the semantic interpretation of natural languages. If these arguments are valid, the prospects for a fruitful interaction between theoretical linguistics and AI are much brighter than they would otherwise be. References: Cope-Stake, Anne-Alicia 1992. The Representation of Lexical Semantic Information PDF DPhil Thesis. University of Sussex. OCLC 39162903. Archived from the original PDF on April 29, 2015. Gazdar, Professor Gerald James Michael. Who's Who? Volume 2015 Online Oxford University Press ed. ANC Black. Subscription or UK Public Library membership required.